Hi everyone, welcome to my memory management presentation. In this presentation, we'll probably compare best fit and first fit algorithm. So this is a Java program that runs a simulation that we can use to compare both programs graphically. So I run the Java program and it's running from the background. It will open a graphical user interface so that we can test it. So let me adjust the interface to the middle of the screen. So here we are going to give the memory block a couple of inputs to check the allocated space the program will give it. You run with the first fit algorithm. So first let's give it a 25 unit space. So we allocate it and followed by, let's give it about 15 sorry 115 and we allocate that one too. Okay, now we can see we have about 50 units of space available. So let's give it a bigger input. Let's give it about 30. Here we notice the first phase can't find a suitable space for the 50 units. Despite it had a bigger space left, total free memory. So here we try to deallocate the memory because so the 30 is very big for the space. So let's try a smaller one. The rest is about 10. Okay, let's locate it. So we'll try with the best fit using similar input sizes. So initially we started with 25, so we start with 25 again and we allocate it, followed by 15, we allocate it, and lastly 30, and we allocate it. Okay, and let's try to deallocate the memory spaces. We deallocate the memory spaces 30. Let's give it about 10 to 25. We deallocate it, and lastly about 15 or 10, 15. We deallocate it. We noticed the best fit was able to find a space to allocate for all the memory inputs we gave it. Well, so here we noticed the first fit was somehow faster than the best fit, and the best fit was more efficient in allocating space for the memory inputs. So first fit might cause a higher external fragmentation, and the best fit on the other hand will lead to a lower external fragmentation. Right, so let's check which algorithm is suitable for some systems. So for the first phase, we can deduce that it will be suitable for embedded system, Internet of Things devices, and other computational resources. The rationale behind this is the first phase prioritizes speed over storage, because if you calculate the complexity, you will notice it's somehow linear compared to the best fit, which is exponential. Moving on to the best fit, you will notice it might be suitable for a large system and multi-purpose operating systems like servers, desktop operating system, and applications that have a larger system of application. So the rationale behind this is it reduces fragmentation and it prioritizes space over speed. That's what most of the operating system we use today uses. Thank you very much for your time.